Ever wondered how software applications are tested before they reach you? Well, it's an intricate process known as software testing. This process is an essential phase in the software development lifecycle, ensuring that the software you use meets the required specifications, performs optimally, and delivers the quality you expect. Software testing is like a safety net, catching bugs, defects, and vulnerabilities early in the development process. This allows our trusty software developers to fix these issues before the software is deployed. It's all about guaranteeing that the software works as it should, providing you with a seamless user experience. From unit testing individual components, through integration testing of interconnected modules, to system testing of the entire software, and even acceptance testing against user requirements, each stage has its unique importance in the grand scheme of software testing. So, are you ready to explore this fascinating world? Join us as we delve into the intricacies of software testing. First up is unit testing, the most granular level of testing. This form of testing hones in on individual components or modules of your software, examining them in isolation to ensure they function as expected. Think of it like a health checkup, but for code. It's the first line of defense in catching bugs early in the development process. Developers play a key role here, crafting test cases to validate the behavior of functions, methods, and classes. They're like the detectives of the coding world, sleuthing out any potential issues that could derail the software's operation down the line. To make this process efficient, developers often use testing frameworks. These are like toolkits, providing a structured way to conduct tests. Some popular choices include Unit for Java or Unit for .NET. So, by focusing on the smallest parts first, we can ensure that the building blocks of our software are solid. Unit testing ensures that each individual component of your software is working as expected. Once the units work perfectly, it's time to see how they interact with each other, which brings us to integration testing. Now, integration testing is all about ensuring that the individual, independently functional modules of your software can play nicely together when integrated. It's like a symphony orchestra where each musician is an expert on their instrument, but the real magic happens when they harmonize their performances. Similarly, each software module may perform flawlessly on its own, but the key is to ensure they interact and interface seamlessly when combined. Integration testing focuses on testing the data flow, communication, and interactions between integrated units. It's like checking the electrical wiring in a house. You want to make sure the current flows smoothly from one room to another without any glitches. This form of testing is essential because it uncovers issues that may not be visible during unit testing. Integration testing ensures that all parts of your software work well together. Now, let's move on to system testing, where we evaluate the entire software system. System testing is like the grand rehearsal before the final show, where the entire software system is put to the test. It's all about validating if the system complies with the specified requirements and if it's able to function in various environments. It's the phase where we simulate real-world scenarios and user interactions to check if the system behaves as it should. Imagine you're building a car. System testing is like taking that car for a test drive, ensuring that all parts are working together, from the engine to the brakes, the lights, and the air conditioning. It's about testing the whole product in its entirety and not just individual components. Next, let's talk about acceptance testing. This is the stage where we validate if the software meets user acceptance criteria and business requirements. It's about making sure that the software is ready to meet the world, ready to be used by end users, and that it meets all stakeholder expectations. In acceptance testing, we have two types: alpha testing and beta testing. Alpha testing is done by internal users, usually within the organization that developed the software. It's like a dress rehearsal before the final performance. On the other hand, beta testing is done by external users, usually a select group of end users who test the software in their own environment. This is like the final dress rehearsal with an audience before the show opens to the public. In essence, system testing ensures that the entire system is functioning correctly, while acceptance testing validates that the software is user-friendly and ready for its intended audience. Both are vital in ensuring that the software is of high quality, reliable, and ready for deployment. These testing phases are essential steps in the software development lifecycle. They help identify any remaining issues that might affect the user experience or the software's functionality. By catching these issues early, we can ensure they're addressed before the software is released. System and acceptance testing make sure that the software you receive is both functional and user-friendly. What happens when the software changes? That's where regression testing comes into play. As software evolves, new features are added, bugs are fixed, and improvements are made. But how can we ensure that these changes don't break the existing functionality? Enter regression testing, a type of software testing that focuses on retesting previously tested features to detect any regressions or unintended side effects. It's like a safety net, catching any issues that may have been introduced during the software's evolution. But stability isn't the only concern when changing software. Performance is another key aspect that needs to be monitored. That's where performance testing comes in. Performance testing evaluates the software's responsiveness, scalability, and stability under varying load conditions. It's about asking questions like, how will the software perform if we double the number of users? Or can the system handle peak load times without crashing? Through tests such as load testing, stress testing, and scalability testing, we can identify performance bottlenecks and optimize the system to ensure it remains fast and responsive, no matter the circumstances. And let's not forget about security. As software changes, new vulnerabilities may surface, making the system susceptible to unauthorized access, data breaches, or malicious attacks. That's why security testing is crucial. It involves conducting penetration tests, vulnerability scans, and security code reviews to identify and eliminate potential threats. It's about building a wall around your software, keeping the bad guys out, and the data safe. So when we talk about regression, performance, and security testing, we're talking about safeguarding the software's stability, speed, and security amidst change. It's about delivering a product that not only works as expected, but also stands up to real-world conditions and threats. With these types of testing, we ensure that your software remains robust, fast, and secure even after updates. Finally, we come to usability testing, which is all about the user experience. This type of testing is pivotal as it assesses the software's ease of use, intuitiveness, and overall user experience. It helps ensure the software meets and exceeds user needs and expectations. Imagine a beautifully designed car that's impossible to drive. It might be aesthetically pleasing, but if the user can't operate it effortlessly, it's not much use, is it? The same applies to software. It's not enough for software to be functional and secure. It needs to be user-friendly and intuitive as well. During usability testing, real users are observed performing tasks on the software. Their feedback is gathered and analyzed to identify areas of improvement. This feedback is then used to enhance the software's usability, making it not just easy to use, but a pleasure to interact with. Usability testing makes sure that the software is not just functional and secure, but also enjoyable to use. Now that we've covered the types of testing, let's talk about the process. The software testing process is a thoughtfully structured sequence of steps, each playing a crucial role in ensuring the quality and functionality of your software. It begins with test planning. This stage sets the foundation for the entire process. It's where we define the objectives, scope, and strategy of the tests, considering factors like project requirements and constraints. In a nutshell, test planning is about asking ourselves, what are we testing, why, and how? Once we've got a plan, we move on to test design. This is where we get into the nitty-gritty of crafting test cases, scenarios, and data. It's like creating a blueprint for your tests, detailing every function and performance aspect that needs to be validated. We're essentially setting the stage for the software to show us what it's got. Then comes test execution. It's showtime. This is when we run the test cases and observe. We record the test results and keep a keen eye out for any defects or anomalies in the software. It's like a performance review where the software is the star, and we're the audience, critically assessing every act. But what happens when we spot a glitch? This brings us to defect tracking and management. Here we log the defects, prioritizing them based on their severity and impact. We then track these issues until they're resolved and closed. It's a bit like having a to-do list, but instead of tasks, we're dealing with bugs that need to be squashed. Finally, we arrive at test reporting. This is the grand finale where we summarize our findings in a comprehensive report. We detail the test results, defect metrics, and overall test coverage, providing a clear picture of the software's quality and performance. It's like delivering the final verdict after a thorough evaluation. And that, in a nutshell, is the comprehensive process of software testing.